test them as an individual unit again, but based on the modification which we do, then during the integration test, we can identify where is the defect. Because at the unit level, this unit is already developed, is already tested, and it might be working fine in a previous project. So in that case, we don't need to repeat the unit test. So this can be another reason for some companies who is giving importance on this component reuse. So they will able to skip the unit test. Got it? Can I understand about that reason? So in that case, we have total of three reasons. Correct? Can I recall back the three reasons? The first one was, can I get the three reasons which I have discussed just now? When we can ignore the unit test. Okay, lack of time, lack of budget. Actually, we don't really use it for skipping unit test because unit test is not using high cost. So the second point is actually when the unit is small and simple. So it means low risk simple. I mean low risk function or unit. Then the third one is the component reuse. So it means when they have these units which is already developed, already being used in the previous project, so we can reuse them. So when we reuse, it means we can guarantee that these units were already tested. So we don't need to test them again. So we can directly do the integration, and during the integration we can test them. Okay, so that will be the three reasons. Okay, let's move to the next question. Differentiate regression test and retest. So this one also I have discussed. Before we go to regression test, what you understand about retest? What you understand about retest? When you see the word retest, what we do here? I'm not talking about regression test. It's a retest. To test again. Okay, it means we are repeating the same test again. You get? Repeat test. So it means we have test, and then maybe we have some reason, and then we need to retest. It means repeat the same test. So when we repeat the same test, there might be no changes happen. It means nothing is modified, nothing is changed, but we are repeating the test to confirm maybe the result. To confirm if the result what we get earlier is accurate or not. Did we test correctly? Is this what it's supposed should be? Especially like let's assume when it's failed test case. So we want to check, is it supposed should be failed or did we wrongly do something? So we repeat the test to confirm something. Okay, this is what we call as retest. So nothing changed. No. Okay. But when we set the regression test, it's still repeating the test, but every time when there is changes happen on the source code. Okay. So let's assume when we do the test and then we identify a defect. So we need to do the debugging. Am I right? So when we do the debugging, There might be some changes on the source code happen, some modification happen on the source code. Then we need to conduct the regression test to confirm after the debugging there is no issue, there is no new defect. So whenever we said changes on the source code, this can be due to debugging, it can be due to adding a new function or removing a function or modifying a function. So all this, whichever bring changes on the source code, we need to conduct the regression test. So it means we test the entire system again. We test them again to confirm that after the changes, the system is still working fine. There is no new problem, there is no effect on the performance, the system able to perform efficiently, there is no delay in the performance. So this need to be confirmed. So the regression test is actually every time when there is changes happen on the source code, the system will be tested again. So the main difference between regression test and retest is every time when there is changes happen on the source code, we conduct regression test and repetition of the test. Retest means not because of any changes happen, but we are repeating the test to confirm the result or to fulfill the requirement. For example, let's assume your client said the test entry criteria is actually where you need to do 2 cycle of tests. So it means once you've done the first cycle, you do the second cycle. So it means there is no changes happen, but you are repeating the same testing using the same test case again. But when it comes to the regression test, if there is any changes happen on the source code which might need changes on the test cases, then it means we need to do changes on the test case before we conduct the regression test. Got it? Clear? So these two tests is totally working for different purpose. Okay. Can I move to the next question? Okay. What is the difference between driver and stop? So just now we were talking about driver and stop, right? So how you are going to differentiate them? How you will differentiate driver and stop? How we can compare them? Can we say actually they are this both of this term, I mean driver and stop, they are actually dummy code. Okay, dummy code, yes, that is the similarity of this. But where we are using it, yes, the level where we are using it can be a comparison. So it means driver will be used at the main module. Okay, it means higher level of the system, while stub will be used replacing at the terminal modules, which is the lowest level. Okay, this is where we are replacing them. If the missing code is at the higher level, then we actually use the driver to replace. Okay. Then if we are having a missing code at the lower level or the lowest level, then we need the stop. This is replacing. Okay, so when we said how this being used, sorry, this is stop to test higher level, driver to test lower level. Um, yeah, actually we can use this higher level, lower level about where we are replacing the dummy code. Okay, where we are replacing it. The second way how we can compare them is driver, since it's replaced at the higher level, it will call the lower level code or lower level module, because it is at the higher level, so driver is having the higher level access to call the lower level module. And when we said stop, this stop is being replaced at the lower level. Am I right? It means it cannot have the access to call, but it is going to be called by the higher level module. So you need to know how you are actually doing the comparison. The first comparison is where we are replacing them. The dummy code is needed at the higher level, which is the main module, or it is needed at the lower level, which is the terminal module. So driver will be used to replace the dummy code in the main module, or we can say higher level in the hierarchy, and stop will be used to replace the lower level code or the lowest level. This is replacing part. Okay. Then the second comparison is, since driver is replacing the dummy code at the higher level, then it has the power to call the lower level code. Okay, and since stub is being used to replace the code at the lower level, it has no power. So what will happen? This stub will be called by higher level code or higher level module. Okay, then the third comparison is when we do top down approach. Top down means we already completed the higher level code. That's why we start from top. So we will need to use stop to replace the bottom part. And when we say bottom up approach, it means I have completed the bottom part. So I don't need to replace with anything. So I might need to I might need driver in this bottom up approach, because I have done the lower part, but I need someone to call it. So I need driver. Okay, so this is the three things how we can compare the driver and the stop. Which level we are using to replace the code, and then either it is being called or it has the power to call. And the third one is in the strategy in the strategy which we will use. So based on which strategy, which one we need. Okay, but in non-incremental, it will be needed both of it, because there is no special strategy being used. So it will actually needed both of it to replace the higher part, to replace the lower part. Okay, clear? Can understand what is the difference? Okay, the similarity is both of this is to replace the missing code in the program when we want to do testing, especially integration testing. Okay. Okay, the last one, the last question here. Give an example of an artifact that to be tested, reviewed for each stage in a V model So I think the first part of this chapter we have a V model diagram, right? Okay, and discuss what are the quality attributes. For example, this can be more than this. Okay, to be tested for the artifact. Okay, in the V model, what will be the artifacts we produce? I think we have three levels in the V model: requirement, design, and coding. Can you please check back the V model in the chapter 2 slide? Is it correct that we have three? This three level which I said: requirement, design, and also coding. Is it correct? So for each of this level in the V model, we need to produce the artifacts. So what will be the artifacts for each of these? I think we have discussed this in the tutorial one about the artifact ready. So our concentration is about the testing which we will conduct and what will be the quality attributes. Okay, so the artifact suppose should be SRS for the requirement stage, SDD for the design stage, and then the code for the coding stage. Okay, so now if you see your V model, this SRS will be used to prepare acceptance test, because user to do the acceptance test, so they will refer back to the requirement given by the user. Okay, then SDD, software design documentation, will be used to prepare uh, integration test. So if the integration has been done according to the design, we are according to the architecture, according to the model, the diagram which we have prepared. Okay, then the third one, the artifact, is the code. So this code will be used to test the unit test. So each of these artifact will be used to prepare this testing. So when we want to conduct this testing, okay, so what are the quality attributes which we need to check on this artifact? So when I say SRS, which is the requirement document produced based on the user's requirement, which will be used for the acceptance test later. What are the quality attributes we need to make sure this SRS has? What can be the quality attributes we check on the SRS, on the SDD, on the code? Normally, SRS means we will say the correctness. It means the requirement must be correct based on what the client said. The completeness, there is no missing requirement happen. There is no conflicts of requirement happen, and the requirement must be consistent based on what multiple users say. Am I right? So for SRS, this will be the quality attributes which we concern about. So when we said SDD, after we produce SRS, we move to the SDD. So when we want to check the quality attributes on SDD, what it will be? The document must be, can we say that the SDD must be correct based on the SRS? The SDD must be uh, consistent based on the SRS. What else? What else the SDD document should concentrate? Um, Correctness, consistency, um, completeness. I don't think so because correctness suppose should be okay if we do the design correctly based on what the requirement said. Then it means it's already complete. Um, okay, I think that too. So how about the code? What can be the quality attributes we check on the code? So this is no more document like SRS or SDD. It's a source code. So what will be the quality attributes? What is the quality attribute here? Yeah, maintainability. Okay. Performance. How to say? Performance. Normally, what can be affecting? What quality attributes affecting the performance actually? The code. What is the quality attribute of the code which can give a better performance? So maintainability is the code must be easy to maintain. It means when we want to do the maintenance activity later, like corrective maintenance, perfective maintenance, adaptive maintenance, so it must be easy to do maintainability. But when we set performance, what is the quality attribute which is affecting the performance to high or low? Can we say the efficiency of the code can affect the performance? Some logic what we use, right? Different people has different logic sense. So the way they write, that can actually decide the efficiency of the code, how fast the logic actually can work or how slow it can work. So when the efficiency is there, then it can make the performance better. If the efficiency is not there, then it might be affecting the performance. Okay, time and space complexity, is it based on the efficiency just now? Because this efficiency can actually disturb the performance time. It can also disturb the performance based on the storage, how the code work actually. Okay, other than that, what else? uh, Reliability, is it needed for us to check on the code? Reliability is more to, I think reliability is more to the system itself, right? The system must be reliable so that there is no downtime happen. How about security? Did we need to concern about the security of the code? Do we check that? Security of the code. Maintainability, efficiency. Do we need to check the correctness of the code to do what the function suppose should do? Do we need to check on the correctness of the code? Which one? Security, reliability, correctness? I need another one more. Which one is the most suitable one? faster. Let's end this tutorial so that we can start tutorial 3. Which one can be? Modularity. Modularity is more to the source code, how it can be easily moduled. Am I right? For example, like how the all the relevant code is moduled together. Correct? Please do let me know if I'm explaining correctly about this modularity. It means the module, all the, for example, when we said all these functions is about the student. So this, all the relevant functionality, we combine them together in one module so that it can be easily tested later. Is that what is meant by modularity here? So that our testing can be easier later, so that it will not be affecting the other code from other modules. Correct? I think it should be under your software engineering before, right? How we are combining this functionality. Is it based on the relevant functionalities, or is it like by accidentally? I think there was under the design part. Okay, I think modularity can. So it means the way we do the coding, it must be correctly moduled together so that it can give better quality or better way how we can easily do any debugging or to do the testing, or how it can actually not affecting other part of the module. Okay, so that should be okay. So efficiency, maintainability, and also modularity. Okay, so that's it for our tutorial 2. Any question? Before we move to tutorial 3, that should be a short one, I believe. Any question? All okay? Tutorial 2? No means any question, no, or everything is okay, no? I have 2 questions just now. The no is what? No question. Or not okay? Okay. So let's move to, okay, great. So let's move to tutorial 3. So I have discussed the static test chapter, okay, on Monday. So let's see the questions. So hopefully we can settle all the questions. Okay, so question 1, describe static testing. So what you understand about static testing? Maybe you can say based on what is this, or when we do, how we do. So what you understand about static testing? Please share me answer. I'm tired of giving answer. Give the answer, we will discuss. Describe static testing. Please with your own understanding, that is very important. Not just copy paste something. You need to understand. So what do you understand about static tests?